Okay, so we'll talk about the row and column spaces. Row and column spaces. If we have a matrix with n by m order, for example, if we have n by m matrix, so in this matrix, the row space of this matrix will be the one which will be the subspace in Rm, which will be spanned by the rows of A. And similarly, the column space of this matrix will be the one which will be the subspace of Rn, which will be spanned by the columns of A. So n by m matrix. So if n rows and m columns, so the row space will be the one which will be in Rm, and the column space will be the one which will be in Rn. Okay, so let me explain this with the help of example and then some other terms as well which are related to that. So what we mean by this is we take two examples. So first example is in this matrix. If we have a say 3 by 3 matrix, 1 0 1 2 1 3 and 1 minus 1 0. If we have this matrix, and then we apply the row operations on this matrix to convert it into the row echelon form. So by the row operation 1 0 1, and then it will be 2 minus 2 will be 0, 1 minus 0 will be 1, 3 minus 2 will be 1. So the row operation will be minus 2 times row 1 plus row 2, that is row 2. And then for this, the row operation will be 1 minus 1 is 0, minus 1 minus 0 is minus 1, 0 minus 1 is minus 1. So the row operation is minus R1 plus R3 is R3. Another row operation 1 0 1, and then 0 1 1, and now we can add these two rows 0 0 0. So in this case we have chosen a matrix in such a way that the last row is 0, although it's not necessary, but just for this illustration we have chosen a matrix in which we have this last row will become 0. So this row operation was minus R2 plus R3, that is R3. So in this matrix now this is the in this matrix is in the echelon form. So in this matrix in this form we can see that there are how many rows are non-zero rows. So first row is a non-zero row. That means a non-zero row will be that row in which at least one element is non-zero. So in this case 1 and 1 are non-zero elements. So similarly second row is a non-zero row, but the third row is not a non-zero row, it is a zero row. So number of non-zero rows in echelon form will form the row space. Okay, so that means the row space of this column is the first two rows in the echelon form. So this row space will be then represented by in the form of a set and vector. So 1 0 1, instead of row we will represent it as a column vector, okay, and then 0 1 1. Okay, so this is the row space of A. So we can represent like this: row A. So row A means row space of this A is 1 0 1 and 0 1 1. So this one. And once we calculate the row space of A, we can also calculate the column space of A. So what will be the column space? So column space will be the corresponding columns in matrix A. Okay, so what is the corresponding column? Corresponding to these non-zero rows, or we can also say that corresponding to the pivot columns in the echelon form column. So in the echelon form column is this. In this case, the first two columns are the pivot columns. Okay. The third column is not the pivot column because it's the last row was 0. Everything was 0 over here. So first two columns. And then corresponding to these first two columns, in the original matrix A, the first two columns were this. So that will be the column space of A, okay, in the original matrix. So the column space of A will be then this matrix. Will be then the set of these two vectors, 1 2 1 and 0 1 minus 1. Okay, so this will be the column of A. Okay, so in addition to now we have found the column space and row space of this given matrix. There is a term which is called as the rank of matrix. Rank of matrix A. So the rank of matrix A is actually the dimensions of the row space and the column space. So in this case, the dimension of the row space is 2. Okay, and similarly the dimension of the column space is also 2. So both dimensions will be same. So that will be the rank of matrix. So it will be either the dimension of row A, or which will be also equal to dimension of column A. Okay, that means either the dimension of the row space of A or the dimension of the column space of A. So that is 2. So the rank of matrix is 2. Okay. The next thing which we can also determine from here is the basis of nullity. Okay, basis of nullity. So what is basis of nullity means? Nullity, as we can see that we have also done it before. The nullity is calculated from this relationship. Okay, Ax is equal to 0. Okay, that means we consider the homogeneous situation. Okay, so in this homogeneous situation, what we can get over here is 1 0 1 and 0 1 1. This was the echelon column. So in this case, if we want to find the x1 x2 x3, so from the second equation, what we get is by the back substitution. So for example, second equation, we get x2 plus x3 is equal to 0. So from here, if we take x3 is equal to s, then we can get x2 is equal to minus s. And then from the first row, we get x1 plus x3 is equal to 0. So x1 will be equal to minus x3, so minus s. So in this case, the solution of x will be this matrix minus s, minus s, and s. Yeah. So, or if we take s as common, so it will be minus 1, minus 1, and 1. So this minus 1, minus 1, minus 1, that will be the basis of nullity, basis of nullity A. Okay, this will be called as the basis of nullity A. So this can be represented like this. So minus 1, minus 1, 1. Okay, this will be the basis of nullity A. And the dimension of this basis is 1, because there is only one component over here. So therefore nullity of A is equal to 1. Okay, and then we can see that rank plus nullity is equal to m, where m is the number of columns in the matrix A. Okay, so this is called as the rank nullity theorem. Okay, this is called as the rank nullity theorem. It states that the rank plus nullity is equal to m. M is the number of columns of the matrix. So we can see that m was 3, because originally we took the 3 by 3 matrix. Okay, and rank was 2, and nullity was 1. So 2 plus 1 is equal to 3. So rank nullity theorem. Okay, so in this way, then we have calculated how to calculate the row space, how to calculate the column space, how to calculate the basis of the nullity, and then verify the rank nullity theorem in this example. Okay, so that was it, and then let's see one more example. Okay, in this case I take the 3 by 4 matrix. That means with m is equal to 4. Okay, so I take A is equal to this matrix, minus 1, 4, 3, 0, 2, minus 4, minus 4, 2, and 2, 8, 2, 8, 2, 8, 2, 8. So this is a 3 by 4 matrix with that means m is equal to 4, n is equal to 3. So we will verify everything which we did in the previous case. So apply the row operations. So minus 1, 4, 3, 0, and then it will be, we multiply the first row by 2, so it will be 0. That will be 4, and then 2, and then 2. Okay, and then 0. Then it will be so in this case what we did is we will have to multiply by in this case minus 2, and then it will be plus. So we have to multiply by 2. So it will be 8. 8 plus 8 is 16, and then it will be 6 plus 2 is 8, and then it should be 8. Okay, so the row operations were 2 times row 1 plus row 2 is equal to row 2, and then 2 times row 1 plus row 3 is equal to row 3. So further, minus 1, 4, Okay, we will continue this into the next video clip.